Good morning, good afternoon, good day to everyone. Tim Wright here with Chris Chisholm. We're going to talk about MLOps and ML model monitoring and how you can accomplish some of that with StreamSets. Why don't you go ahead and introduce yourself, Chris, and then I'll follow.
Good afternoon. My name is Chris Chisholm, and I'm the Director of Credit Decision Engines for PayPal Credit US. I have been with PayPal now for almost 3 years. And for about 10 years before that, I was a Marine officer serving on the West Coast of the US and a little bit of time in the Pentagon. So I'm here today to give a little bit of business context for the technical work that Tim's going to walk us through in the ways that we use models in a business like PayPal and some of the pitfalls that we see with model management and model deployment. Tim?
I'm Tim Wright. I'm a solutions architect at Access Group, an end-to-end analytics consulting company. I've been here for about 5 years. Initially came on doing machine learning projects, so actually building ML models for customers like PayPal, then sort of transitioned more towards sort of the engineering side of things, helping deploy like ML frameworks and help sort of Chris and some of his colleagues with an ML monitoring framework, and have sort of gradually transitioned more into sort of an engineering mindset and skill set. So real quickly, what we're going to talk about today is what is MLOps and why it matters for companies. Then we'll talk through a basic machine learning workflow and talk about some of the challenges that it presents. Then we'll talk about monitoring ML models and how that may be different than other types of monitoring. And then we'll sort of close out, since this is a StreamSets conference, with a small demo that uses StreamSets. So before we get into MLOps and why it matters, we should probably talk about sort of what machine learning is at its core. So it really is about taking historical data, feeding that to some computational algorithm, which will learn the patterns and relationships in that data to generate some approximate mathematical model of some business phenomenon. And then that mathematical model is used to support decisions. So to contextualize, maybe a telecom company might be interested in which ones of their customers are going to churn at the end of the month. They might look at data like their customers' activity with their platform, their payment history, some competitor activity, maybe promotions. They're going to learn all those, basically the relationships between those to build a model about who's going to churn. Now, the problem is that your mathematical model can at times become out of sync with the actual underlying phenomenon that it is meant to sort of pattern itself after. And when that happens, if you continue using the model, you're going to be making potentially poor decisions. So MLOps is sort of inherently about making sure that the models that you have in production to support those decisions are aligned with the actual underlying business phenomenon that may be transient and changing over time. This is the Data Ops conference. Probably quickly contrast MLOps with Data Ops. I'm going to run through this pretty quickly. While there is no common definition, I don't think, for Data Ops yet, or not one that's fully established, it's largely around delivering data to end consumers in a reliable, consistent, fault-tolerant way. MLOps is that, but it's also additional things. So you have to look at the data and models. You have to version data pipelines and model pipelines and training pipelines. You have to keep track of ML experiments and parameters, monitor drift in your data and your model output, so both input and output. So there's a whole bunch of stuff that you have to do in addition. So I would say in some regards, it's a superset of Data Ops. And ML Ops really, in the absence of automated processes, all of the things that are required to deploy an ML model to production require different teams with different skill sets, a large degree of non-determinism, a lot of manual steps, and sort of all of those things together conspire to make it really difficult to get something from like a lab environment into production. So that's kind of like the academic, what is MLOps and why it matters. Maybe Chris, you can add a little context here from an actual business that's doing this for real.
Thanks, Tim. Yeah, it's a good distinction, right, between data operations and model operations. And for a business like PayPal, the size we are and the speed at which we have to move, deployed models for us are everything. We are using models in every single one of our segments, every single one of our products to really help us make better, faster decisions on behalf of the customer, better, faster decisions on behalf of our merchants, and creating a more secure end-to-end environment. We as PayPal run a two-sided network between merchants and consumers, and the better models that we have, the faster we deploy new models, the more secure environment that we're building. So that works and how you can deploy single models. But for us, this is big business for us, and we do model management and model deployment at the core of what PayPal does. to keep on top of the volume of transactions and customers that we deal with every single day. And then the last piece of that, and we're going to hit on this a little bit more, is the consideration of, new regulations and new regulators. And we being a global business, I mean, obviously changes in banking regulations here in the United States, changes in banking regulations overseas in Europe and the UK have a tremendous impact on the things that we include in our models, the way in which those are treated, both internal models that we use, as well as external models that we may be getting from some of our partner organizations. So MLOps is a big deal for us. There are some very large teams at PayPal doing this every single day. So, a very good technical topic to walk through because this is very real for us.
Thanks, Chris. And yeah, we're seeing that in a lot of industries right now where ML is really becoming core to the operating model for companies. So doing this well really matters. So real quickly, I'm going to talk through a basic ML workflow. It's intentionally sort of bifurcated and split into two streams. The one up top sort of denoted lab, and the one towards the bottom denoted production. So lab, that's really where your data scientists are going to work, and we'll just create a data scientist called Bob. He's working in the lab. What Bob is normally going to do as part of his workflow is take a data snapshot from some real-time system. He's going to take a one-time snapshot, take that offline. Bob's going to work with that in an environment that he feels comfortable with. So maybe that's a Jupyter Notebook, maybe it's RStudio. And in there, he's going to explore the data, he'll plot it, he'll run statistical tests. He's going to generate a whole bunch of additional features that don't exist. And then from there, he'll go ahead and build models. And what this means is really he's going to choose a variety of different algorithms and probably choose a bunch of different parameters and different permutations of parameters and feature sets. So that sometimes Bob's building, 10,000, 20,000, 30,000 different models for sort of one iteration of his workflow. And from there, maybe Bob finds a model that he likes. At that point, he may engage sort of this productionalization team. And it's a team that's got more specialized skills in software engineering, DevOps, things like that. And a few of the critical things here is that Bob's going to have to sort of hand over all the logic that he used to build the features themselves. And he's going to have to hand those off to a different team so that those features can be added to the data in real time so that the data will be conformed to the model that will be deployed. And he may hand over some model artifact that they may stick behind some API endpoint or some other serving framework to actually serve inferences on that conformed data. And then from there, they'll actually score observations in production. So they'll use that model to actually generate predictions. Now that's a very, very sort of basic workflow, but there are a bunch of challenges with it. Sort of across the top, one of Bob's big challenges is, with tens of thousands of permutations of an ML experiment, it becomes very challenging and almost a requirement to track metadata about the data snapshot, about all the features, about the different permutations of parameters and the evaluation metrics. So if you want any hope of reproducibility, which is definitely desirable in all cases and in some cases required depending on industry, you have to basically version everything and keep track of it. Additionally, by taking a one-time data snapshot, you do see sort of a bifurcation in those data streams. And what that can lead to over time is drift between the data that's serving your model and between what was used to build your model. Particularly if Bob comes back 6 months from now and tries to run the same extracts, they may not work or the data may look different. So that presents a challenge. Just the process of translating Bob's logic for his features into sort of production-ready logic, that may mean translating Python code to Java or something that's more performant. Could mean a whole host of things. But if you're not translating the logic itself correctly, you can wind up with a situation where you've got a conformed data model where the schema is consistent with what it should be, but the actual meaning of the values, if the logic hasn't been captured one-to-one, may not be consistent with what it was during training, and that can lead to poor performance down the road. And additionally, you've got trouble or challenges when it comes to actually deploying the model because your model is tightly coupled with the data pipeline that feeds the model. So if you don't have automated processes in place, it can become very challenging to roll out new models or do something like canary deployment, or if you find a model that's misbehaving, to roll it back because you constantly have to make sure that these two things are in alignment. Otherwise, you're going to have challenges. Then lastly, once you do have a model that's serving inferences and producing predictions, you actually have to do something in order to keep an eye on it and monitor those and make sure that they're behaving. And we'll talk about that a little bit more shortly. So MLOps really is the collection of all the practices aimed at addressing all of these challenges and more that we're not going to get into today. Again, that was a relatively sort of abstract, maybe academic discussion. Chris, maybe you could talk about sort of what that means for you guys, how that challenge is exacerbated and maybe even amplified for you guys at PayPal.
Thanks, Tim. So Tim and I talked about this part of the presentation. We described it as the old cartoon, how does a bill become a law, right? And for us, at PayPal and for Tim, folks like Tim out building models, I think about it really as, how does a model become a business decision, right? How do you, building models and deploying models are only good so far as you have to make a decision, right? They're driving some sort of business decision. You're trying to get some sort of business outcome with that model. And it's not just models built and deployed in a vacuum. Depending on the regulation of your industry, depending on where you are, the model can sit in the middle of a very time-consuming and very complex process where you have compliance checking in to make sure that you're hitting the right variables, you're hitting the right times. You have legal tipping in to make sure you're adhering to the right standards, the right legal standards and guidance, depending on your agency. You have all of the governance layers, right, associated with making sure that tests are completed on time, testing to, ensure that the models work and they're giving you the right values are completed on time. And then finally, you have a team, like for us, there are teams that take those model outputs and actually make decisions based on them to say, hey, you may give me a range of 1,000 in a particular model score, but we have strategy teams that then come in and say, okay, well, I'm going to use this very tight range of that particular model to drive an outcome, to include folks or to change this or to change that, depending on what the model, the intended use of the model is. And then finally, we have feedback loops, right? So once those rules go into production, right? Once those models actually go into production and those strategies get written into production decision making, we have feedback loops around monitoring, right? And it is, how good are the models performing, right? Which is what Tim's gonna hit on next. And there's also other kinds, right? How good are the decisions that we are making using those models to say, what are the outcomes we intended to drive? And are we achieving those? And are there other parts of the model that we could leverage or furthering the score bands that we're using to drive better business outcomes? So it's getting a model from, a fully developed deployed model all the way to a business decision is not done in a vacuum, depending on the type of industry that you're in. So, Tim, I'll leave it to you for the next round on model monitoring.
So, as Chris mentioned, really that's sort of the final step of that whole process is basically monitoring things and making sure that they're behaving as expected, because that's going to really alert you that you need to go back and change something, right? If it were steady state and consistent, you wouldn't have to worry about that, but that's never the case. So, monitoring really forms a sort of critical pillar. But monitoring ML models is specifically challenging. Part of that, it's very difficult to determine, why is it performing poorly? Like, how do you even tell that it's performing poorly? So there's a few things that could happen. One is concept drift, where maybe your data looks identical to the way it did last year. Maybe the range of values are the same, the fields are the same, everything looks identical, but the relationships in that data may have changed. And that's what your model is really based on. It's trying to uncover that relationship. So for example, maybe the things that were causing fraudulent activity last year aren't the same as what caused fraud this year, or pre-COVID, maybe the phenomenon looks different than post-COVID. So that's known as concept drift, and that's challenging to ascertain. And there's also, of course, data drift, where maybe your data schema changes, your fields change, or it could be something as simple as, the fields look the same, but the distributions of values that you're seeing now may look different than they used to. For example, maybe you're getting a whole lot more younger customers compared to older customers. An additional challenge is that when you've got a prediction actually in production, oftentimes it's impossible to determine whether or not that was an accurate prediction. And the reason that is because, for example, if you're a customer or if you're a company and you're making decisions on who's going to churn, you might get a prediction once a month saying these are our customers that are going to churn this month. Usually, you're going to actually use that prediction to what Chris said was take a decision or make a decision to try to impact or affect some outcome. So maybe that means you're going to give them some sort of promotional discount. As soon as you go ahead and interfere, it becomes impossible after the fact now to say, was your prediction correct or was it incorrect? So it becomes really challenging. So what's commonly done, and sort of these are some of the metrics that are often used, are more related to measuring how stable do populations or distributions look over time. So here's a few metrics. I'm not going to get into them specifically, but they're just metrics of similarity between distributions. And what's often done is you might take the predictions that were produced at the time that you built the model, you take that full set of predictions and you plot a distribution with it. Then over time, you sort of continuously benchmark incoming predictions and say, how similar is the distribution of these predictions? How similar is it to the predictions that were produced when we built the model? And once those deviate, that sort of gives you some signal that something has changed and you may be having performance issues. Of course, that's going to lead to additional questions like, what thresholds should I use on these non-deterministic metrics, and sort of what intervals should I be monitoring my models at? Should I do this once a week, once a month, every hour? And there really is no straightforward answer. It's definitely dependent on, what's the point of the model, what kind of decisions are being made with the model, how critical are they? If it starts misbehaving, what are the impacts of a misbehaving model? All of those things sort of jointly have to go into building a strategy around how to denote that it's not performing well and to generate sort of the metrics in this non-deterministic sort of environment. So I'll kick it back over to you one more time, Chris, and maybe you can talk about some of the specifics again at PayPal here.
Yeah, so just a couple of challenge areas, right? As we look at from building models, building and deploying new models, to monitoring existing models, deploying existing models, and then kind of looking for some of the upstream issues, right? So as we're pulling together new models, and we've got we have teams dedicated to building our new models, we have to get the business aligned on what the purpose of those models is and what the intended outcome is, right? So is it are we trying to reduce losses? Are we trying to increase profitability? Are we trying to, what's the point of the model? And getting all the teams that have, that are interested in the performance of that model swimming in the right direction as that model is being built. There's obviously lots of stakeholders, there's lots of inputs, but we try to really balance the highest priority items as we're going through kind of new model development. To the second piece, right? So how do we, as models mature, as we go from one model version to another, or we create new models, we're constantly working through changes in data. Our data structures may change. Our data providers may change. We may get new providers. We may launch in a new country. And all of those have implications for the ways in which the model will be developed and deployed. Data is rarely perfect, especially as you're kind of expanding into new markets and working with new data providers that you may not have worked with in the past. And also around strategy. To Tim's point, we are going to make a decision. We're going to use the models to go out into the business and make a decision. And what are the ways that that kind of self-selection is influencing our models down the road? If I'm only letting so many folks in, and my models are influenced by the folks that are in my population today, then I'm gonna have an issue, right? I'm gonna have an issue with the way that those models are trained in the future. So we're always kind of looking for new sources of training data on those models. And then the last one, Tim and I talked about this a little bit earlier this week. One of the interesting things that happens down the road, and we go through it often, is upstream data providers, right? Folks that we have existing relationships with to provide data. Those upstream sources may change or they may break. And making sure that we've got monitoring in place, automated monitoring and alerting in place to notify the business when something upstream from a model falls apart or changes in some sort of meaningful way. That, more and more as we come to rely on external partners for feeds into our models, that can be a very big deal. And that's something that we are constantly on the lookout for.
Thanks, Chris. So jumping back over to this workflow, I just want to highlight that we're going to talk about sort of how, given, again, this is a StreamSets conference, how we can address maybe this last issue, monitoring with StreamSets. So we'll jump into a quick demo here. But before I do, I just want to talk to you. The demo is going to calculate a single metric. I just want to talk to you and give you sort of a little bit of an intuition about what that metric actually is. So it's a metric that's called the Population Stability Index. It's relatively simple to comprehend. You're essentially going to take your prediction scores when you built your model, so during training, and you're going to split those into an equal number of bins. So you're going to take 10 bins and put 10% of your prediction values in each one of those bins based on the range. And that sort of establishes your baseline. Then over time, as you get live scores, you're going to take a sample of those live scores, be it a week, a month, a year, and you're going to take those scores and you're going to allocate them into the same bins that were generated from your training data. And then it's more or less a simple comparison between the proportion of your training records in that bin compared to the proportion of your actual predictions that are being generated real time in that bin. A simple mathematical sort of comparison of those allows you to calculate sort of a contribution, this last column, PSI contribution. And then you sum that across all the bins to get this, this one aggregate score. So here is 0.66. So that metric, sort of 0.66, would tell us that, these two distributions are dissimilar. And that, incidentally, at 0.66 in this data does actually represent the bars on the right. So normally for PSI, it's less than 0.1 is about, is considered stable. Between 0.1 and 0.2 is somewhat in the middle, and above 0.2 we consider to be somewhat unstable. So real quickly, I'm going to go ahead and jump over and play a video that we recorded yesterday of this demo, and we'll be back in a second. So I want to quickly demonstrate how you can leverage StreamSets to bootstrap an ML model monitoring process that you could use for a suite of ML models. Here I'm just going to show you how you can use StreamSets to calculate a single metric, the population stability index, but this could easily be applied and extended to additional metrics as well. So let's take a quick look at the pipeline that I built, and it's this one here. It is a transformer pipeline, so it leverages Spark in the back end. And now you can see it's relatively simple. It takes two inputs, validation data and live scores. The validation data essentially is the predictions that were generated when the model was built during training. And the live scores are the predictions that are being generated by the model in live production. So we're going to feed both of those to the PySpark stage subsequent, which is the population stability index. It's going to take those two data sets and it's going to compare their distributions to one another and generate that population stability index table that we discussed previously. From there, that PySpark stage is going to write the results back to ADLS. So if we look at these real quickly, you see the validation data is coming from this validation subdirectory in ADLS, and the live scores are coming from the predictions directory in ADLS. So if we look at ADLS real quick, we've got two directories, Model 1 and Model 2. Ideally, you'd have a whole bunch of models here. And inside of each one of those, we have validation data and we have predictions. And those represent, again, the data sets that we had already mentioned. So that's where the data is coming from. The PySpark stage that we wrote, and these helper functions are just called at the bottom. So where the magic really happens here is just this last piece. So it takes two inputs, the two inputs that are being fed, calls this build PSI table function, and it generates that PSI table, which is then written back to ADLS. So one other point of note that I want to make on this pipeline is that it is parameterized. So currently it has two parameters, model and metrics. Model is being used, and that lets us know essentially which model are we trying to evaluate with this pipeline. The metrics is really a placeholder for sort of feature enhancement and meant to sort of spur your imagination as to how you might be able to parameterize this further, by possibly passing a list of metrics, and then based on this list, you could have the pipeline conditionally evaluate certain metrics. So with that being said, let's go ahead and create an instance of this pipeline or a job. So we're going to take the pipeline. We're going to create an instance. We want to make sure that it targets the dev transformer. And we're going to use one of the runtime parameters to make sure that we're targeting a single model from ADLS, Model 1. So we're going to go ahead and create this job and start this. And as this is running or starting to run, we'll go ahead and create another instance of that same pipeline in another job to monitor Model 2. And it's that easy for us to essentially use the same pipeline on two different models. And again, you could do this on a whole host of different models if you had them so configured. So this one's finished. This one's just starting back up. But functionally, what this is doing, it's going to drop the results from that PSI table into each one of these subdirectories. You're going to get a monitoring results, and you're going to get the outputs from that in these files, sort of split across those files. What these files actually look like are this. So essentially, we're calculating the bins for the PSI table calculating all the metrics that go into those bins appropriately, and then finally calculating the contribution of each one of those bins to the PSI score. And then to get the aggregate PSI, you could aggregate and sum across these, okay? And then with that metric, now you've got a measure saying how dissimilar are the predictions at runtime versus training time. And from that, you could basically set a threshold that was reasonable and actionable for your organization and action on that. And that's sort of the moral of the story here, is that we've created a single, simple pipeline that can be extended and applied to a variety of different models simply by changing the configurations. In this case, the only thing was the model, but you could certainly enhance that moving forward. With that, I think that's the presentation for us. Hopefully, we've given you a little bit of context about what MLOps is, why it's important, maybe how you could leverage StreamSets to get something started in terms of monitoring or addressing that component of MLOps.